Hey, what if I told you that in 80s, even before I was born, people was using something like ChatGPT. So you sitting, steering in a console, and in a plain English, ask the system the questions, and system give back you the answers. And it was the main idea of the computer of the future that, for example, the Japan government was so keen to build, and that was the future of the fifth or fourth generation of the programming languages and so on. And after that, something happened, and actually, the first IE winter happened. And what kind of the technology was behind of all these amazing things from 80s, and what these things we could use today to make our artificial intelligence actually, and our personal information and personal knowledge smart enough. So last time I talked with you about the Prolog and artificial intelligent languages, and actually this magic system, it was the expert system built on Prolog that was majority of the Prolog based programs are interactive, and they based on the idea of the deductive database that you could query, and you could query it with the predicates, or you could query it with the plain language if your Prolog interface just do the parsing of the natural language. And Prolog was quite good for the symbolic reasoning, and Prolog was quite good for the actually the parsing and natural language processing. But what we could take from these magic systems. So the core of this magic system was deductive databases. And deductive databases actually is the cool thing because they consist of two big parts. So first part is the extensional database. So extensional database actually it's quite similar to relational database because it's just a set of facts. Every fact consists of the predicate that have a name, so it's similar as a table name, and some set of parameters. And actually, the same predicate name and same array of the parameters create the fact. So something like person, and then you have the parameters like the name, date of birth, and so on. So right now it's extremely boring because it's similar to the relational database. But even this extensional database already give us quite interesting property together with the Prolog. It's the uniformity that right now you could just ask the database the simple questions. And yeah, but the magic came with the second part of the deductive database, that together with the facts, you could describe the rules. And it's extremely interesting because rule, it's some kind of equation that from one part you have the predicate with the parameters as same as the fact. And from other part of the equation you have the fact or the rules that connected with the logical operations like and or something like that. That's it. And that's mean that you able to express the complex rules or complex facts about the facts that already exist in a database. And it's mind-blowing because I just make the article how to apply this principle to the knowledge graphs, to the personal knowledge graphs, how to encode with the rules actually the ontology and semantics of the data. That, for example, you could go and say that something like relation love, it's something that happens between two persons and with some special relation in between, and so on and so forth. And it's mean that you have one language that able to express the facts and the rules, and able to express the complex relation between the facts. And for example, in the area of the personal knowledge graphs, we have ability to express the complex entities as a facts, and relations between these entities, and even more. We could create the high-level rules that will unify the different entities to some concept like node. So we could say that node could be the person, or it could be the skill too, or it could be the location, or it could be something more, or it could be some abstract node, because we don't have right now the type of entity for this new knowledge that we infer from your information. So we will store it for the future. Maybe you will find some common patterns in the future. So the Prolog, and especially the data log, the subset of the Prolog that more data oriented, it's super efficient, elegant, and super cool in expressing complex knowledge, in expressing personal knowledge graphs, in expressing the complex entities and the relation between these complex entities. And believe me, something like the graph processing in the data log will take you 2 lines or 4 lines, and a similar code will take 600 lines in a Java, or even 300 lines in Python, and so on. So deductive databases have a superpower of combining the facts together with the rules, and deducting the facts based on the logic knowledge, the more new knowledge that you haven't described in facts. So it's super powerful. It could change the market of the personal knowledge graph. It could change and simplify the tasks that right now we try to hit to the LLMs and SLMs, and try to solve these challenges with the large language models, but they're not so suitable for this. Maybe for the reasoning and complex deduction, we still could use the logic programming and deductive databases. And I see the huge space of using the deductive databases as a personal knowledge management systems, personal knowledge management graphs, and personal graphs as a deductive database. I shared the link near the video about how to do it in a data log, and how to do it in a souffle as a dialect of data log, and I have an article already on the Medium how to do it. And I really believe that it's important for the artificial intelligence, it's important for the sovereign data, and it's quite important for the personal knowledge management space. So we could apply it with the majority of the different tools that are available in a personal knowledge management space. So if you're keen to know more, just read the article, comment, subscribe to our channel, subscribe to our videos. And if you have questions, I always happy to answer them. So it was all that I was keen to share with you. See you next time. Tschüss.